Example 2. Well, in this example, we're going backwards throughout this. They're giving us our final point that we're eventually going to land at, which is 12/6 with those two arms. And then what we know is we want to find, in addition to knowing the arm lengths are both the same. It's 5 square roots of 2 and 5 square roots of 2. What we want to know is how much do I have to rotate in order to make this situation happen. Okay, and one of the easiest, I guess there's two pictures. I kind of drew a picture over here on the right where we found the length of A. I just went ahead and did that for you guys. It's just using Pythagorean's theorem with our points 12 and 6. Okay, and one of the easiest angles that we can at least solve for, first of all, without having to do much, would be theta 2. It's going to be, by the time, you all can see as I drew this triangle right here, if this is 100 and if this is, it's not a right triangle, but if this represents a straight line right here, if I know that this is 180 minus theta 2, then that would right there would be theta 2. So how I'm going to do is try to find this interior angle right here using our law of cosines. Okay, to find theta 2. All right, law of cosines. What that says is, remember, since we're trying to find this angle, we want to start with the side opposite of that angle. So we're going to go with a squared, which in this case is, so it's going to be the square root of 180 squared is equal to the sum of the other two sides squared. So 5 square roots of 2 squared plus 5 square roots of 2 squared minus 2 times those two sides times the cosine of the angle opposite this side, which is 180 minus theta. All right, so squaring a square root is just 180 is equal to 25 times 2 plus 25 times 2 minus, okay, so 2 times 5 times 5, 50, and the square root of 2 times the square root of 2 is 2, and then cosine of 180 minus theta. All right, let's finish working with this a little bit more. So 180 is equal to 50 plus 50, which is 100, minus 100. All right, right here. Remember the formulas for cosine when your angle has more than one thing in it? It's always the cosine of the first times the cosine of the second, opposite, so plus sine of the first times sine of the second. Okay, so moving down some more. So 180 is equal to 100 minus 100 times cosine of 180. Well, the cosine of 180 degrees is a -1, so this will be a negative cosine theta right there. And the sine of 180 degrees is 0, so 0 times anything is 0. Okay, so let's move this 100 over. So 180 minus 100 is 80, is equal to a -100 times a negative cosine theta, 100 cosine theta. Okay, so cosine of theta is equal to 80 over 100, so or 8 over 10, which is 4 over 5. And since I'm solving for an angle, then we're going to get theta is equal to cosine inverse of 4/5. Okay, and when I plug this into my calculator, I get an angle value of 36.87. So 36.87 degrees. Well, now that we have our theta value, I kind of wanted to also tell you guys a little something. We have a little trick here. Remember that rule back in the time where it said that cosine of theta is equal to also the cosine of negative theta? Well, we need to realize that we actually have two options for this answer. Theta could either equal 36.7 or, and I guess in this case we've been always solving for theta 2 in here, or theta 2 could be negative 36.87. And if you want to, just take your calculator out real quick and plug in a positive point of, take the cosine of positive 36.87 and see if you get 4/5, which is roughly 0.8. And then plug in the cosine of a negative 36.87, and you realize you'll also get 0.8 because it's all based on this formula right there. Okay, now how does this pertain? Why the two answers? How does this pertain to our problem? Well, it's because we can actually draw two technical pictures. We can draw one picture where the second part of the robot's arm is rotating up, or we can draw a picture where the second part of the robot's arm is rotating down. Okay, so it's like, let me see if I can draw this for you guys real quick. If we have first part of the robot's arm going to here, and then the second part going up to here to the point 12.6. So this would be technically the quote-unquote elbow going up option, or we could have the robot's arm coming here first and then going over to there to land up. And then this would possibly be the technical elbow down possibility. Okay, so this is kind of an intricate problem because in the sense that we have two options. And yes, we're going to explore both options. Well, let me get some space cleared out. Let me erase some of this stuff, and then we'll consider part one, maybe the elbow up solution, and we'll do part two is the elbow down solution. Okay, so then to do the elbow up position, what I did is just kind of redrew what we have already, specifically that we know that the length of the kind of like this hypotenuse or whatever, or this side of this triangle, is that square root of 180 that we found up here, and we just got through finding theta 2. And specifically, since theta 2 is positive, we're doing the elbow up position. So you rotate your arm, your first arm to here, and then from there we're going up through the positive theta 2. Okay? All right, now, so what we have to do is find theta 1. And how we're going to get theta 1 is kind of like some stuff that we've been looking at before. If we can kind of treat this as a right triangle right through here, where we have the height of this right triangle is the y value 6, the length down here on the base is the x value 12, and then my hypotenuse right here is that square root of 180. Okay, so if I have that, then I know that I can find all of this using the tangent. Let's call this tiny little angle right in here of this triangle, let's call that alpha. So if I go the tangent of alpha plus theta 1, then I get tangent, remember, is always the side opposite, or it's your y over your x. So it's going to be 6 over 12. Okay? Or do we just have to find out tangent of alpha plus theta 1 is going to equal 1/2. And then if we want to get rid of tangent on that left, we can say that alpha plus theta 1 is going to equal the inverse tangent of 1/2. Well, I can find the inverse tangent of 1/2, no sweat whatsoever, using your calculator. And then I can definitely find alpha, because we're going to find that here in just a second. So as long as I can get alpha, then right away it's solved for theta 1, because theta 1 will be the inverse tangent of 1/2 and then minus alpha. So let's go about just finding alpha real quick. Okay, so how are we going to get, let me come down here for a second, give us some room. How to get alpha? Well, you see how we have this small triangle in here, and it's not a right triangle, and that angle right there is alpha. How am I going to get alpha? Well, I've got several sides that I can work with. That is the square root of 180, and both arms, remember both arms that they gave to us just a second ago was 5 square roots of 2. Okay, so we can list that side as 5 square roots of 2, and this side is 5 square roots of 2. Okay, so if it's up to us, if we want to use the law of sines or we want to use the law of cosines, I can get that angle right there because that's what we added, whatever you have to add to 36.87 in order to get 180 degrees. So that angle right sitting in there, technically, is, 180 minus 36.87, which is, if we want to, we can call it 143.13. So that's the angle right there. It's kind of up to us. At this point, we can do law of sines or we can do law of cosines. Since we've done law of cosines before, up just a second ago, let's look at the law of sines. Okay, so the law of sines says any side divided by the angle opposite, or the angle divided by the side opposite. So let's go with here. How about sine of alpha over the side that's opposite, which is 5 square roots of 2, is equal to one angle that I know, so the sine of 143.13 degrees divided by the side opposite that, so square root of 180. Okay, so now just kind of working with this a little bit, so we can get sine of alpha. I just multiplied, both sides by 5 square roots of 2. Then we'll get sine of alpha to be 5 square roots of 2 over the square root of 180, and then times the sine of that 143.13 degrees. Okay, and to get alpha by itself, we're going to do the inverse sign then of all of this. So 5 square roots of 2 over the square root of 180 times the sine of 143.13. All right, let's see what we get when we plug this into our calculators. And when I do it myself, then I get alpha to be specifically, looks like 18.45 degrees. Okay, so now let's use that to answer our final question. And by the way, alpha looks pretty good to me because that was definitely a very, very, very small angle of that part of that triangle, so definitely for sure. All right, so theta 1 now is the inverse tangent of 1/2 minus 18.45 degrees. So when I plug that in my calculator, then I get theta 1 to be, looks like, kind of rounding a little bit, 8.12 degrees. Okay, so there's theta 1. And if we come back up here, then we can say, our theta 2 is 36.87. And there's the answer specifically for theta 1 and theta 2 when I've done the elbow up position. So let's see what, if we get kind of something similar, or let's see what happens when we do the elbow down position. Okay, so here for the elbow down portion of the saw, we basically still have that first arm that's come up, it's rotated through theta 1. And now for our second arm, we're coming down to the point 612. If we do some things that we've done right before in the elbow up position, if we drop this side down to form a right triangle here so we can get some information going on, where this is our hypotenuse, which we found to be that 100 square root of 180 like before. The height here is definitely the y value of that coordinate, which is 6, and the length down here is the x value, so 12, and there's my hypotenuse. So this time, if I want to try to use my tangent, and then obviously it's going to be of just this portion of the angle right there, if we call this interior angle alpha, then I know for a fact that tangent of, let's take the difference of those, theta 1, which is all the way up to there, minus that tiny little alpha part, would then be the interior angle of that right triangle. Okay, so theta 1 goes, let me show you this. Got some parts here. Theta 1 goes all the way up there. So if I subtract off alpha, which is that little piece, then all I'm getting is this angle right in here, and that's what we're looking to find to use our right triangle. Okay, so the side opposite, so 6 over 12. So now to get the angle by itself, so theta 1 minus alpha is going to be the inverse tangent of 1/2, or theta 1 is going to be, this time, the inverse tangent of 1/2 plus alpha. Okay, and now what to do with this whole alpha thing? You know what? We get to actually use the same alpha that we had before. So we had alpha, because it's still, no matter what, the smaller triangle, the non-right triangle, is still going to have the same angles as what the other one did. So when we got an alpha of 18.45 degrees, we get to use that again. Okay, so going back up here then to theta 1, so we don't have to do it hopefully as much work this time, which is kind of nice. But it's the inverse tangent of 1/2 plus 18.45 degrees. And so by using that and plugging in our calculator, then we're going, by the time we round a little bit, it looks like we are going to get theta 1 to equal roughly 45 degrees. So there's theta 1, and then theta 2 right up here, that was when it was the negative 36.87. Okay, so that kind of shows you how to work with a robot where you have two potential positions, one an elbow up and one an elbow down.